Hello, seventh grade. We are on week 13th, and this is continental drift. We're looking at evidence for continental drift. And in fact, we are also looking at evidence for seafloor spreading. So at the end of this lesson, you should be able to explain what magnetic stripping is and how it supports continental drift and seafloor spreading. Magnetometers in the ocean discovered strange patterns. These patterns of stripes are like what they've discovered on the seafloor. In this image, there is a dusky purple stripe in the center. Other colored stripes are symmetrical on either side of the dusky purple stripe. In the oceans, magnetic stripes are symmetrical about the mid-ocean ridge axis. What does this have to do with continental drift, you might be asking? Well, we'll find out. Warships also carried magnetometers. Magnetometers were like echo sounders in that they were used to search for submarines. The magnetometers also revealed a lot about the magnetic properties of the seafloor. Looking at the magnetism of the seafloor, scientists discovered something astonishing. Many times in Earth's history, the magnetic poles have switched positions. North becomes south, and south becomes north. When the north and south poles are aligned, as they are now, geologists say it is normal polarity. When they are in the opposite position, they say that it is reversed polarity. Scientists were even more surprised to discover a pattern of magnetism on the seafloor. There are stripes of different magnetism. Some stripes have normal polarity and some have reverse polarity. These stripes surround the mid-ocean ridges. There is one long stripe with normal magnetism at the top of the ridge. Next to that stripe are two long stripes with reversed magnetism. One is on either side of the normal strip. Next come two normal strips, and then two reverse strips, and so on across the ocean floor. The magnetic strips end abruptly at the edges of the continents. Sometimes the strips end at a deep sea trench. Scientists found that magnetic polarity of the seafloor was normal at mid-ocean ridges, but reversed in symmetrical patterns away from the ridge center. This normal and reverse pattern continues across the seafloor. Magnetometers are still towed behind research ships. They continue to map the magnetism of the seafloor. Different seafloor magnetic strips equal different ages. By using geologic dating techniques, scientists could figure out what these ages are. They found that the youngest rocks on the seafloor were at the mid-ocean ridges. The rocks get older with distance from the ridge crest. Scientists were surprised to find that the oldest seafloor is less than 180 million years old. This may seem old, but the oldest continental crust is around 4 billion years old. Scientists discovered another way to tell the approximate age of seafloor rocks. The rocks at the mid-ocean ridge crest are nearly sediment-free. The crust is also very thin there. With distance from the ridge crest, the sediments and crust get thicker. This also supports the idea that the youngest rocks are on the ridge axis, and that the rocks get older with distance away from the ridge. This is because the crust is new at the ridge, and so it is thin and has no sediments. The crust gets older away from the ridge. It has cooled and has more sediment. Seafloor is youngest near the mid-ocean ridges and gets progressively older with distance from the ridge. Orange areas and red show the youngest seafloor in this picture. The oldest seafloor is near the edges of the continents or near the deep sea trenches, and they are colored light to dark blue to purple. This leads to an important idea. Some process is creating seafloor at the ridge crest. Somehow, the older seafloor is being destroyed. Finally, we get to the mechanism for continental drift. So in summary, Data from the magnetometers dragged behind ships looking for enemy submarines in World War II discovered amazing magnetic patterns on the seafloor. The magnetic pole reverses from time to time. The North Pole becomes the South Pole, and the South Pole becomes the North Pole. Rocks of normal and reverse polarity are found in strips, symmetrically around the mid-ocean ridge axis. The seafloor is youngest at the ridge crest and oldest far away from the ridge crest. The oldest seafloor rocks are about 180 million years, much younger than the oldest continental rocks. So if you're able to explain what magnetic stripping is and how it supports continental drift and seafloor spreading, feel free to move on to the other activities. Otherwise, take some time and go back and review the video. It's been great talking to you. We'll see you again soon.